Okay, we're going to do a quick abbreviated version of Friday, and then I'm going to see if maybe you have a little bit more confidence as to number 5's answer and what you think it is before I tell you what you think it is, what I know it to be. There you go. Should probably actually look at it while I'm teaching to see what the correct answer is. Anyway, example number 4. So things that you should have gone through on Friday, and stop me if you're like, I didn't get when that video. Is that cool? Okay. Example number 4. What are the directions specifically asking you? Ooh, polar. It's all different because now they can tell you like, hey, I want one leaf. Hey, I want the inner loop. Hey, I want between the inner loop and the outer loop. Hey, I want inside one circle and outside the other circle, what they share, what they don't share. Why is it so different? Because it's polar. Not parametric, but pause. Behind the scenes, what's the formula we're using every time for area of a polar curve? Oh, sorry. 1/2 r squared d theta. All having to come back to this geometric sector thingamabob, whatevs. 1/2 r squared. Need a theta bound to begin and to end it. So on this one, in essence, I need a 1/2 with theta bounds with r squared d theta. Now, is it super hard to do most of this problem? Or at least most of the setup? No, but what is hard? Okay. I would rewrite this to be. Does anybody know, just looking at this curve, have you done enough pre-cal review of polar at the beginning of homework to know why this is a limacon with an inner loop? Okay. What does cosine go between? If cosine can be -1, can't this r be a negative number? And if r is a negative number, what does that mean with polar points? You're going the opposite direction. So pi over 3 negative means go the other way. So you're going. You're going inside anytime there is a plus b sine or cosine of theta, and it can be negative, you have an inner loop. So since it can be negative, 1 minus 2 would be a negative number. This has an inner loop, but when does it happen? Guys, for all the limacons you're going to see, they're going to be centered around the pole in some way. They might have symmetry around the polar axis or around the pi over 2 line, around the x or around the y, the old x, old y. But still, that inner loop is going to happen around the pole, which means solve for the zeros. Solve for the zeros. Because it's going to have to hit the pole to start the inner loop and hit the pole to get out of the inner loop. Wherever that inner loop is, whether it's one of these guys or whether it's one of these guys, actually, it's going to go down a little bit. Or whether it's one, however it's oriented, it's going to have to go through the pole twice to start and to end the inner loop. Now, some of you are like, well, I wouldn't have known that. Okay, well, did you at least get a sketch? At 0, you could plug in cosine of 0 is 1, 1 plus 2 is 1, and a 2 and a 3. P.S. This is the biggest this can go is 3, because the biggest cosine can be is +1. Did you then plug in cosine? He's gross anywhere but pi over 3. At pi over 3, isn't cosine 1/2? So cosine of pi over 3 is 1/2 times 2 is 1, and 1 plus 1 is 2. All right, fine. Cosine of pi over 2 is 0. 0 plus 1 is 1. Should probably be up a little higher. What's going on? I'm coming in. Awkward. There we go. Then what? We could keep on going, but guys, when is cosine going to hit 0? At 2 pi over 3. Because at 2 pi over 3, it's going to have come in. And then when else is cosine going to be 0? At 4 pi over 3. If you checked at pi, cosine is -1, 2 times -1 is -2, plus 1 is -1. It comes in on itself. That's what I meant by that. And it comes back out at the pi over 3, and then it's going to be symmetric for the rest of the time. Okay, all that to say, you could have just gotten a sketch and seen the beginning and the end of the loop. It could have just happened naturally as you sketched. Or you could have said like, oh, hey, doesn't that happen at theta equals 2 pi over 3 and 4 pi over 3? So some of it is just getting familiar with the polar curves as far as, oh, inner loops always start and end at the pole. Sweet, let's find some zeros. What else starts and ends at the pole? Petals. Starts and ends, starts and ends, starts. Ooh, always starts and ends, like nicely. No, if this was switched, it might have started on half a petal and then gone to a whole petal, whole petal, whole petal. But still, zeros? Zeros? Ooh. Was this a graphing clue on the forever card that we talked about on Thursday? Sometimes can help to find the zeros. That's what I meant by that. It's not really something to memorize, more of something to be understood, which is why I had you all try number 5. Because if you understood petals started and ended at zeros, you should have found zeros to start. Does that make sense? Okay. Now, number 5 is one step harder because it says, oh, they gave you all sorts of different bounds. Pause. Just going towards homework. Guys, how would you solve this by hand? Power reducing after you FOIL. Should I have any trouble integrating this? No, no big deal, right? Isn't it just going to be 4 sine of theta? Integrating this, no big deal. It's just going to be theta. But what am I going to have some struggles with? Now I can pull that out and I can make that a 2, but then I have the integral of cosine squared. Oh, wait a minute. What are my bounds? Could I do 2 pi over 3 to 4 pi over 3? Yeah. And what would that find for me? The whole inner loop. But couldn't I also have doubled going from 2 pi over 3 to pi? Why would I do that? Why would I double and say, let me only go halfway and then let me double it? Pi might be easier to plug in because sine of pi is 0 and cosine of pi is -1. It could be nicer on my head. But either one is right. This is right and that is right as far as expressions for the integral. Except now it's right. Sorry, it was wrong. But I would need to change cosine squared. Let's see, if I'm doing my 2 pi over 3 to pi because I'm lazy and I don't want to have to go to 2 different pi over 3s, then doubling 4, right? Oh, no, I kept him. Because I already took the integral of him and him. Sorry, I haven't written it yet. But then I'd have 1 plus cosine of 2 theta all over 2. Not magic, it's math. It's the power reducing formula. So I can go ahead and I can pull out the 1/2, so I have 2. And then can't I integrate 1 to be theta and cosine of 2 theta to be 1/2 sine of 2 theta? What did I just do to get that 1/2? Yeah, I used sub. And then I still have my 4 sine of theta chillin', and I have my theta chillin', and all of that needs my 2 pi over 3. I did one by hand because I wanted you to see the practical application of power reducing. We can't integrate that. There's no way. Unless we do the power reducing formula. Pre-cal comes to life. If I had taught you pre-cal, I would have been like, this will be important in CalcBC. This is the day. Okay. You should. Let me ponder life though. What's going on with this guy if it says the total area enclosed by? Who's sine squared of theta? You have 2 options. One option is start making a table. Another option is to memorize all of this. Who's the sine squared? He's one of... He's not even one of our special ones? Well, that's kind of sad. He is going to be an infinity one because of our reducing formula, because I could make him a 1 minus cosine 2 theta all over 2. Yeah, that's not. Good try. But you guys could have graphed him too. Where's sine nice? Not at pi over 3s. Where's sine nice? Pi over 6s. Sine equals 1/2 there, right? But the nice thing is, why am I only going to 1? How big does sine get? Oh, sine? 1 and negative 1. So what's 1 squared? 1. What's negative 1 squared? 1. What's the biggest he'll go? 1. So that's 0. Isn't he at 0? At pi over 6, isn't he 1/2? And 1/2 squared would be 1/4. At pi over 2, isn't he 1? And 1 squared is 1. At 5 pi over 6, isn't he 1/2? And 1/2 squared is 1/4. He's kind of boring. At pi, isn't he 0? Well, there's one part of him. What happens when we go, though, to the second quadrant? Sorry, the third quadrant. 7 pi over 6. That's 1/2. Ooh, it's negative 1/2. But square it, what is it still? 1/4. And then 3 pi over 2. Oh, it's negative. No, but squared. It's positive. Okay, remember positive r's. You go out towards the angle, and then it's going to be a positive again. So how long did it take me to complete? And if you keep going, it's just going to happen again. Yeah, it's going to keep going and going and going. It's going to keep going and going and going. So, yeah, kind of. Total area. Can't I just do 0 to 2 pi? Couldn't I also? Couldn't I also go 0 to pi times 2? Which 2 times 1/2? If you were to do this by hand, though, why am I taking time on this? But we can't do sine to the 4th. We need power reducing. Yeah, you do. But how many times? Isn't that just a squared? So wouldn't I need a squared squared? That's sine squared squared. Struggle. But when you FOIL this out, what do you end up getting? Don't you get another squared? Because if I FOIL this out, that would be 1 minus plus I can integrate. I can integrate. I can't. What do we have to do again? So I'd have 1/2 theta minus 1/2. Oh, 1/4. Good call. Good call. I didn't square that. That's dangerous. So that'd be 1/4 theta. I can do him. That would be 1/2 and 1/2 would be another 1/4 using u sub. But then I would still need him again. So that'd be, wait a minute, how do you do the power reducing formula when you have a 2 theta inside? 1 plus cosine of 2 theta would be 4 theta. You guys see what I'm trying to show you? Just little places you can make mistakes. Now, y, pull out the 1/2. Doesn't need to be a 1/4. It's not squared this time. And then you would do u sub again. Is that okay, though? Okay. Here was endeavor number 34. And here's where it might have gotten funny. Friday. You guys saw me on Friday in the video do the polar sweep thingy, right? Where because my bounds are theta bounds, we're going out thetas, like pi over 6s, pi over 4s, pi over 3s. Does that idea make sense? Okay, so we're not going from x to x, from y to y. We're going from theta to theta. Radiuses, right? Okay. So area between. Wait, pause. Hold on. Pause. Number 5 doesn't need area between. It's one curve. It's one leaf. Let's talk about number 5. One curve, one leaf. 4 sine of 2 theta. What would I have advised you to do? Well, first of all, I would advise you to think of 1/2 r squared. But the problem is, couldn't they have done some symmetry junk and done it 2 times? Okay, so maybe let's not just look at the... Well, hold on. Is letter A or B squared? Well, forget that. Like, I need r squared. So cross off A and D. But now let's think about bounds. Did anybody set 4 sine of 2 theta equal to 0? He's not squared. He's not squared. Forget that because I need 1/2 the integral. I don't know, some theta that I don't know. And r squared. Technically r squared d theta. They aren't squared. Forget him. Couldn't we have set this equal to 0 if petals start and end at 0? So then I could go ahead and get to divide by 4, still 0. Sine equals 0 at 0, pi, 2 pi, 3 pi, 4 pi, all over the place. But 2 theta has to be that, so I have to divide everybody by 2. So my zeros are, I don't know, 0. Every pi over 2 is going to be a new 0. And aren't these the same distance apart? Which means a whole petal, whole petal, whole petal, whole petal. Oh yeah, there's 4 whole petals. Oh. Well then, couldn't I have just gone from 0 to pi over 2, because that guy's the same as that guy, and done 1/2 r squared? But I don't see any 0 to pi over 2s. Okay, forget that. Well, technically, this is going to be the 4th quadrant, right? And all of these are positive numbers when you plug in. Are they all positive numbers? But either way, petal, 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 petal. Is there a pi over 2 to a pi? Oh, there's one. Is there a 3 pi over 2 to a 2 pi? There's one. Oh, his period's way off. 0 to pi, that's too much, right? Okay, so both of these have bounds that would be a petal. So what do we have to do now? Yeah, let's just plug in. So if either of these bounds would work, either of them would maybe not get us that petal, but get us a petal, which would be the area of each petal. Are we okay with symmetry? So could we just plug in 1/2 of, okay, forget the bounds. Both of those are valid, and I just need r squared. That'd be 16 sine squared of 2 theta. What's the only one that matches up with 1/2 of 16? Letter B. Questions? Does it make sense, though? Use the zeros and plug into the formula. They didn't even do the symmetry trick. They could have done something nasty like, what would they have done? I don't know. Pi over 2 to 3 pi over 4. Double. They wouldn't have done that. But check it. All the petals are the same. So they can use whatever petal they want to find that one. But if you guys are like, oh, it's 3 pi over 2 to 2 pi, I'll choose that one. But you have to make sure it works with my 1/2 r squared. Yeah, I agree, Kathy. It wasn't nice. I know. It's the AP. Okay. So now area between. Is there an area between in our practice test? Number 9. But number 9 doesn't say between. Number 9 says the area of the region common. Oof. So hold on. Can you guys check out the area between card and realize it's not just an area between card? What do you see? Area between and area. Between would be in one, not in the other. Both would be shared. This card is just saying, okay, what if you have 2 curves? Area between, we're going to be subtracting. Area inside both, we're going to be adding. What the heck is going on? I'm hoping in the video this helped a little bit. But guys, can I go ahead and zoom in as much as I can to this dude? This dude, the example that you guys were doing Friday, was saying outside the cardioid, outside the cuspy one, inside the circle. Okay, outside the cardioid, inside the circle. The cardioid's a little cuspy one, a little heart one. The circle is this dude. Okay, I'm going to make circle the red guy. And I'm going to make cardioid the green guy. Christmas, that's weird. Must be patriotic. July's closer. Okay. Do you see the area they're asking you to find? Isn't it this area? And don't we have intersection points? Right here and right here. True? So why would area between be subtracted? Well, this one actually kind of makes sense, maybe. Because when you do area, don't you go out angles? If I do that, aren't I in trouble and I have too much area? I'm not supposed to have this. It's also. So what do? I subtract. I subtract the red minus the blue, and I get the gray. Do you see it? If I go out radii, the red is going out to the red. And as he does, he doesn't care about the blue. He's going to get that whole thing. The blue says, no, 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 no. I'm here too. You need to get rid of me in order to get what it is that you're wanting. Kind of makes sense? That's area between. That's why you have to do of 1/2 r squared of the outer radius and then 1/2 r squared of the inner radius, because I have to find area between. But the other one is area inside both. Aha, here we go. What's this one say? Inside r equals 2, which is just going to be the circle with a radius of 2, and inside the limacon, here's the little limacon with barely like a little divot. Inside both. Can I zoom in on this real quick? Inside both. Isn't that this right here? I'm going to go ahead and pull up a highlighter, just so I don't have to cover up stuff. Do you guys agree this is the inside both part? Right? Okay. But what if I was to do the same thing? Where I have my circle being red, and I have my limacon with a little divot. I don't know what's going on there. I guess we can call him a cardioid. He kind of has a cusp. He doesn't go into the hole. I technically have intersection points here. Now there are these things called true and false intersections, but we don't worry about that until AP review. Don't worry. What if I went, well, the mock AP. What if I went to the circle? Am I getting some area? I'm getting area, I'm getting area, I'm not getting area anymore. I don't want to go to the circle anymore at all. There's no purpose in going to the circle. Where should I want to go now? Plus. Why am I stopping? Well, forget that. If I have this, I'll just double it. Symmetry. Why is it addition? Because part of the inside part will be going to one curve and to another curve. So I'm going to have to go from theta 1 to theta 2 with the red, 1/2 r squared, and then I'm going to go from theta 2 to theta 3 with the blue, add the two together and double it, and I'll be done. Okay. What have we talked about today? The endeavor cards, basically, right? The area one and the area between and the area inside both. Why do we talk about the endeavor cards? Because I'm afraid that we might have gotten stuck in homework a few different places. Now guys, we only have 7 minutes, but do you have any places in homework specifically that you're like, please, can you just get me started? Can you just get me finished? Can you just get me to the right answer? Yeah. 64. The rest of us, it's due by midnight tonight, and what are you bringing to me tomorrow? Questions on what? Whatever you want. Practice test, homework, whatever you want. Now pause. Did I talk about last week how Con and Patrick and Dr. Marchese, whatever her name is, and everybody else who does calculus online, how they have videos about polar curves? Okay. That might be something we need to check out at some point. But you just got from me the big idea of the formulas. Naomi, yours was number 60? Yeah. 50. In between. You guys ready to practice what we just did? Okay. What are these pictures? Oh, some of you, your weakness right now. You're like, I don't know. Okay, what would you do with that? Sure, you can visualize. You can think hard, or you can just start making a table. Okay. Well, hi guys. How are you? Welcome to calculus. Class is almost over. Why am I going to make my radii go out 3? Just looking at these two. How do I make that deduction? I'm just trying to help. Cosine can be 1, so the biggest this radius can be is 3. 1 times 3. The biggest this one can be is 2. Right? 1 plus 1 is 2. Okay. I'm going to go ahead and make him red. I'm going to make him a different color that I'll do when I get there. Cosine of 0 is 1. 1 times 3 is 0. It's going to be great. Ugh, he squared a 3 over 2. He squared a 2 over 2. He's always 1/2. I like the pi over 3s, right? So if cosine's 1/2, 3 halves, okay, whatever, that's all right. 1 1/2. Whatevs. Yeah? Okay. Cosine is 0 at 2 pi over 3. Cosine's negative 1/2. Negative 1/2 times 3 is negative 3/2. How do I go negative 3/2? The other way. 1.5. Ooh. He's going like this. Yep. Cosine of pi is negative 1. Negative 1 times 3 is negative 3. Whoa! He finished in pi. Because guess what's going to happen when you go here? It's going to be negative again. So it's going to be back here and here. It's going to be positive again. It's going to go here. He's doing 2. His period is actually, you wouldn't see it there. I know, it's a struggle. He's going to finish in pi. Okay, so there's one curve. Who's the other dude? It's all right. Don't stress. Just start plugging in. So plug in 0. Isn't cosine 1 and 1 plus 1 is 2? Is that good? Okay, 0 line going out 2. And then cosine's 1/2 and 1 plus 1/2 is, oh! What did we just find? An intersection point. And we found an intersection point without even, yeah. And the really cool thing is they happen to both happen. They cross that at the exact same time. Which is a good thing, because if they cross at different times, we'd have a whole other issue in our hands. So at pi over 3. I'm too lazy to erase. At pi over 3, we have an intersection point, right? Not only the paths, but also the particles on the paths. They're going to collide. Where do we go after that? 1 plus cosine. We're back to the him. So my 1 plus cosine. Pi over 2. Cosine is 0. 1 plus 0 is 1. He should technically probably be. I don't know. And then, what else do I have? Cosine at 2 pi over 3 is negative 1/2. Negative 1/2 plus 1 would be 1/2. There. And then he's going to be 0 at pi, because negative 1 plus 1. Then he's going to go out, because there's symmetry. I love symmetry sometimes. And then he's going to go out, and then he's going to go. Here's the question, though. Did I even really need to get the whole little cardioid cuspidum? What happens on the half happens on the other half. Find the area that lies inside the circle and outside the cardioid. Inside the circle and outside the cardioid. Inside the circle and outside. You guys see him? Inside the circle, outside the cardioid. So how do I do that? Don't I need to go to the circle for a time? Isn't that way too much area? Oh, I didn't intersect it. Bummer, man. Sorry, guys. My picture was bad. I was having too much fun for a bit. Oh, it's a bummer. Now he's way in the way. Anyway. So if I do my circle from 0 to pi over 3 of my 9 cosine squared of theta d theta, that's way too much. I'm going to have to subtract. And who am I going to subtract? Why? Because that's the way I need to take away the blue. So Naomi, that's ultimately the formula that you would want to use. You would have to, wait, ooh, this is important. Before tonight, 11:59, you're supposed to have your homework done. What did I say about problems you had to do by hand versus calculator? Because you have to know how to do both. Do 2 by hand, do a calculator. 2 by hand, do a calculator. 2 by hand, do a calculator. So I don't know where it fell, Naomi. Maybe just throw it in. You can do it in function mode or you can do it in polar mode. Oh, if it was a by hand one, then you have to do some power reducing. But was your setup the same? It was the exact same? Okay. Guys, I'm going to keep playing on this just because this was Naomi's question. Something went wrong in the mental math. Is that cool? Tomorrow, what are we going over? Questions on homework and the practice test, but it's also a work day. So like you guys could just be having music in, you could be working, or you could be asking stuff if you're stuck. Is that okay? Okay. Endeavor quiz, let's not have it tomorrow, but be studying. I'll figure out a way to incorporate it either on the test or in a bonus or I don't know. But you need to have those memorized for Wednesday. Cool?
So there's a chapter 11 review in Blue Caution. Is that like a book?
I think it's just your practice test, isn't it? Let me check. It's just the practice test we passed out on Friday. You already have that one? Yes. Yes.
I woke up early to finish.
Nice. All right, Naomi, let me play. Doing okay? I'm thinking of you guys too. Bye. Oh, that could have been it. That could have been it. Because then... Oh, it starts to get really messy right about now, doesn't it? Okay. Hold on. We're just going to keep our bounds. Just going to separate everything. Because then you would get 9 halves and 1 half. Oh, and this all needs to be doubled. Oh, but that's kind of nice because then this can distribute and cancel out him. Okay, that makes it a little bit nicer. So I'd have 9 halves theta plus 9 fourths sine 2 theta, and then minus theta minus 2 sine theta minus 1 half theta minus, oh no, don't. Oh, okay. Minus does that look right? No, it's okay. It's okay. 1 half, and then 1 half times 1 half is 1 fourth. And 9 halves minus 1 half would be 8 halves, or 4. 4 minus 1 would be 3. So it would be 3 theta. Then minus 2 sine theta. And then 9 fourths minus 1 fourth would be 8 fourths, which would be 2 sine 2 theta. 0 to pi over 3. Should be 3 to pi over 3. Is it just pi, Naomi? There you go. going to freeze the screen for you and then